paper number EN019. So the topic name is Intelligent Agriculture System Using IoT. Zarina Sheikh, Samir and Prafull, Sunil, Nitin. Okay, you can share your presentation. Start.
Good afternoon, everyone. My name is Sunil Rajwant. I am pursuing my engineering degree from D.Y. Patil Institute of Technology, Pimpri. My topic is Intelligent Agriculture System Using IoT, and my group members are Samir, THAWARE, Prafull, Sunil, myself, and Nitin. We are doing this project under the guidance of Zarina Sheikh ma'am. So let me start with the introduction. So agriculture provides the major contribution to India as in 2018 50% of Indian workforce depends on agriculture, and almost in that year 17% to 18% uh, profit, the gross domestic progress, it gets contributed to India in a wide scale. Another thing is water scarcity, which is increasing rapidly, and our country is in a situation to save each drop. Thus, the traditional method of irrigation can be replaced by automated irrigation system by using some current technologies. Uh, so, to overcome the sensors like the soil moisture sensors and ultrasonic sensors, the GSM modules are being used. This will improve the cultivation, and hence it will also reduce the manpower. So this is the main point. After that, the motivation of our project is for the farming where various new technologies, they yield higher growth of the crops and their water supply. It's all about the automated control features with the latest technology that we have used using microcontroller. As the irrigation is the artificial application of water to the land or soil, it is being used to assist in growing or agriculture crops, and also the maintenance of landscapes and revegetation of disturbed soil in dry areas is also quite possible. So quite in this our system, it provides well latest electronic systems. The so while literature review, in the author name was Arun and K. Lakshmi Sudha. So the title of the paper was Automatic Irrigation System on Sensing Soil Moisture Irrigation. So in that they have done the irrigation mechanism which turns the pumping motor on or off on detecting the dampness content of the earth. This paper was based on IEEE and the year was 2012. The second literature review is by Mohammad Jimmy Ismail. The paper title was Remote Monitoring in Agriculture, Greenhouse Using Wireless Sensor and Short Message Service. The work of this paper is sending data via SMS in 2014. The next one is about irrigation control system using Android and GSM for efficient use of water and power. This is used to control the system by using the Arduino Uno method in 2016. The another one is microcontroller based control irrigation system for plantation. It is by Arjun Ghatule and SR Kumbar. Their work was made use of Arduino board, which is user friendly, and it helps to dump the programs easily in 2017. The problem statement is water management is paramount in countries with water scarcity. So this also affects agriculture in a large. So the large amount of water is dedicated to that use. So thus the studies that were aimed at saving water usage in the irrigation process have increased over the years. So to avoid these problems and to improve the growth of the plants, automated irrigation system is developed. So therefore, our aim is to develop intelligent irrigation system to water the plants and to inform the user through the message. Objectives to water plants automatically to check the water level with the help of ultrasonic sensors, to check the moisture of the soil with the help of soil moisture sensors, to improve the growth of the plants, and to send the messages to the farmers regarding on and off state of pump via SMS. The proposed system, Praful will explain.
Yes, Arduino Uno. It is the central core of this project. As it controls all the hardware that are attached to it. Then the sensors like soil moisture sensor, water level sensors are connected to this microcontroller. The output of the sensors are fed into this Arduino Uno. Second is soil moisture sensor. It is used to detect moisture level of the soil. When the soil is having water shortage, the module output is at high level. Otherwise, it is at low level. This sensor acts based on this resistance. If resistance is low, then it shows higher moisture content in the soil. And if the resistance is high, it shows dryness of the soil. Then LCD. It is the screen which is used to detect moisture level of the soil. It is used to show moisture level of the soil and the pump status. Then relay module. It is used to control on and off of the watering pump. The relay plays a major role in this irrigation system, and it provides necessary information for the pump whether the pump has to be turned or not. Water pump. It is a component which consists of motor which converts electrical energy to mechanical energy. And this rotational movement increases pressure of water in the tank or well. Since the pressure is high, it takes the water from the well and it is used to agricultural land. Then GSM module. GSM, with the help of GSM, the information regarding the on and off state of pump can be sent to the user. Water level sensor. It detects level of water in the tank. Water level sensor is placed in the tank to determine the water level. And the reference value is given to the sensor as the minimum required level. If the water level goes below the reference level, it gives the information about the water level to user. Then these are the components. Then advantages. About it is architecture of our system. So Arduino is the main. Moisture control level is attached to it, and power supply, water level sensor is also attached to it, and then user will be notified via GSM module. Next slide. This is the data flow diagram. So first it will read the water level and it will check if water level is low or not. If water level is low, then it will fill the tank and it will send status to the user. And if water level is not low, then it will read the moisture level and then it checks if moisture level is low or not. So if moisture level is low, then it will turn the pump to irrigate. And if moisture level is high, then it will again check the moisture level when it will be low. And it will send a status to the user. Next. Maybe you can go to advantages, Sunil. Applications we have done. Application advantages. So the whole irrigation process is automated and labor work required during irrigation using the additional method is also eliminated. Then the large amount of water is saved during irrigation using automated system as compared to irrigation using traditional method. Then the crop receives essential amount of water based on sensor values. So there is no wastage of water. And about conclusion, the intelligent irrigation system can be widely used to reduce wastage of water and to provide the healthy plants and agriculture. In our project, the motor can be turned on and off automatically by using relay, which controls this operation. The plants get the required amount of water from the water tank to water storage that is connected to the motor. Proper monitoring of water level to the plant is done by this project. It provides correct amount of water to plants whenever it is necessary. The health and growth of plants can be maintained. Water wastage has been reduced, which has many economic benefits. Since this project gives benefit in economic side too. In order to avoid water issues in agriculture, intelligent irrigation is the best solution. And future scope. These are the references.
Thank you.
What is the cost of your model?
Hello.
Yes.
What is the cost?
Yes, कोणत्या कॉलेजला आहे ना?
Means, are you saying the cost of this IoT based means components?
Yeah, components, total cost.
It will be, if considering all components, it will be roughly around 1,500 to 2,000.
Okay.
Hello.
Have you done any models? Have you tried any doing any models or is it on paper only just?
No. We have done implementation.
Implementation done already.
Yes.
So why you not included these pictures and those things?
We have implemented. It is like we have implemented in partial. It was in partial implementation. Okay. So we implemented the slides.
Hello. And one more references you are indicating that it is by SMS also it is some literature reviews are there, I think.
Yes.
What is that method actually? How they do that one? SMS.
With GSM, the user will get notified about pump status and the water level sensor and moisture. Yes, moisture as well.
Sensor will send the SMS.
It will detect first water level sensor and soil moisture sensor will detect water level and soil moisture, and it will send status like whether it is high or low, and if pump is turned on or not.
To send the status, which protocol you have used? Yes.
Like we have done this in Arduino Uno, so we have implemented this in Arduino Uno.
Yeah, on Arduino you have implemented
Yes.
protocol. Which protocol you will be using to send the message?
We are using GSM module, ma'am, for this CM900 GSM module.
So
Thank you,
thank you very much.
Yes, thank you, ma'am.
We really appreciate your hard work here.
Can I ask a question actually, if you have a moment?
Yes, sir.
Okay. What is the operating principle or power requirements for the sensor, if you don't mind?
What, sir?
The sensors for moisture sensing sensors you have used.
Yes.
What is the operating principle or the power requirements?
Like it acts on resistance. So if means it shakes dryness of the soil. So if soil is dry, then
how does it operate? What is the power requirement? Is it battery operated, or how does it send signal to the
yes,
app?
It is battery operated.
And how long does the batteries last, and how much do you need per acre of farming or irrigation land, I would say? And did you conduct any studies of how much water in terms of volume or something how much has been saved, since you mentioned it has been partially implemented? So how much water were you able to save?
Sir, it can.
What was the water consumption before implementation, and what was the water consumption after implementation? Is it practical? Is it feasible to put so many sensors in the irrigation and to maintain these electronic devices, and then to conduct the training for the farmers to make them literate enough to use this app and understand what's wrong there? Maybe you can use in this scope anyways.
Yes, sir.
Yes, sir.
Okay.
Thank you, Sunil and Praful.
Thank you, ma'am.